in the state of South Dakota. I work for the Bureau of Information and Telecommunications. Can you see my screen okay?
Yes.
Okay, okay, cool. Hopefully I get everything right here. So I'm a security technology engineer is my official title. I do a lot of an analyst work as well, and even some architecting in the mix on top of that. I guess what I'll be kind of going through today is, there we go. I'm going to talk a little bit of how you can use Elasticsearch and using it as a SIEM to be able to assess all the different telemetry that you got coming into your environment and how you can react and defend your infrastructure with those logs. So I'll kind of talk about how we got to Elastic in the first place. I'm going to go through a little bit of a high level on, what can you do about those remote endpoints out there? I know last year was quite heavy on a lot more work from home and remote endpoints that might not be inside of your infrastructure. How do you handle those assets? How can you solve that problem with Elastic? I'm going to show some basic security operations center use cases for identifying interesting events in your Elastic stack from Windows endpoint logs, and then we're going to go through some of the functionality in the Elastic SIEM called detections. So I got some examples there on what you can do there. We'll just kind of get rolling through here. So where we came from was a SIEM that couldn't quite keep up with the demand. We had queries that could take 5-6+ minutes for looking back the last 3 days. That was becoming unacceptable. We need a lot quicker turnaround for looking at the events that we had. But before that, we wanted to add even more logs to this already big SIEM monster. And, we just couldn't do it from a financial perspective. It was just an absurd amount of cost what it would take to get those endpoint events into the current SIEM that we had. So it was slow and it was costly. So what we did on the side was, we'll build an Elastic stack and just do the endpoint events there. And then we'll do all this stuff, the networking and all other fun stuff, web logs. We'll do that in the other SIEM. What began to happen was we really started to thrive on Elastic with our endpoint logs, and let's go ahead and maybe pull our vulnerability scan data in there as well. We started, seeing the value there. Well, let's maybe do our web logs here, and let's maybe do our firewall. Let's do our ID. And before you know it, everything that we had in that old SIEM had naturally over time been baked into Elastic. So we had a good refresh, and it wasn't by design that, okay, we're going to completely move off the SIEM. It was, let's use this one use case, but it just to be so effective that we could begin to have more use cases and more benefits as we went along. A little bit of a scope, that endpoint visibility, we're talking over 9,000 endpoints. When I said I worked for the Bureau of Information Telecommunications, that is one of 4 bureaus and 22 agencies in the state. So we are a consolidated IT team that provides all of the technology for the state agencies. If that's your game fish and parks, whether that's your Department of Social Services or Transportation, your Highway Patrol, whatever those state agencies are, we provide them the technology. So our Security Operations Center, what we do is we monitor all those systems that we provide, whether it's desktops, laptops, servers, things like that. So, but our focus today, I'm going to really narrow in on endpoint visibility, because I believe you can do a lot with the information that you can glean from an endpoint. Of course, you should do servers, you should do cameras, you should do switches, routers, firewall. You should do a lot of other things as well. But I'm going to show you how much value you can get out of just looking at your end users' devices, the ones that are working on a daily basis, that have that risk of maybe email, maybe browsing the web, those types of things. So I'm going to roll through these things. We want to improve alerting for security incidents, and we want quick incident response times. We want better reports. So after the fact, after something has happened, can we go back in time to see what had occurred? We want to be able to see what is it in our infrastructure that we need to improve upon. And a good example of this is App Locker. Can you bring in your App Locker logs into the Elastic Stack and monitor them with Kibana and see, okay, which applications do we trust or not trust, and then start putting rules in place to block bad applications, only allow the ones that you want. And then again, improve the visibility across all of the whole environment, especially hostile environments, which would be, let's say I take my laptop home, it doesn't get connected to the VPN. How can I continue to monitor that asset if for some reason it's not locked into the VPN, it's just on its own home internet connection? How do I monitor that type of activity? And I'll cover that as I go along. Any questions so far? All right. I like to run through an analogy, but I'll keep this one pretty brief, since I'm sure some of you are pretty familiar with Elastic in the first place. But I like to break it down, and we've got all kinds of fun names for the parts of the stack. I think people like to come up with their own ways of doing this, but I think of all the trees out there are your log sources. What types of trees are you gathering? What types of logs are you gathering for your infrastructure? And you gotta be able to transport all those logs somewhere. And so this is going to be your Elastic ingest or your log stash or your WinLogBeat or something that's going to ship all those events. And then those logs themselves is what you actually want to do something with. In their raw form might not be all that helpful until you do something like process them. And then once they're all processed, then you actually do something with those logs, because you're going to have all different types of logs that have different fields. For example, source IP is always a good example. It might be source underscore IP, or it might be SRC IP, whatever that might be. And so mapping to what's called the Elasticsearch common schema, we want to be able to process all these logs and make sure that they have one common schema. So then we can search source IP against the firewall, search source IP against the Windows event log. So we can search source IP against vulnerability scan data, whatever that might be. We want to make that unified so we can easily search across the infrastructure. So looking at this at enterprise scale, we're going to talk Windows specifically. You can do something similar with your Linux and Mac devices. I won't speak to the other parts of the tech stack because I don't have experience with the Elastic Agent and any of those fun functionalities yet. So I'm going to keep it simple. And I'm going to talk about how you can leverage a free tool called Sysmon, short for System Monitor, developed by sysinternals, that does a lot of recording on a Windows device. And we're running Sysmon on these devices, and we're going to use a tool called WinLogBeat, provided by Elastic, that takes those event logs from the Windows event log channel Sysmon and send those to Elastic to be indexed and to be searched. So when WinLogBeat ships logs, you can take WinLogBeat and ship it straight to Elastic. Or you can send it to Logstash and further enrich them before they get into Elastic. You can also, instead of using a Logstash node, you can use Elastic ingest nodes. And I know we got some experts at Elastic here that can elaborate on that. But for the sake of this example, we're going to use WinLogBeat, send those events to Logstash, and then do our enrichment, and then send them to Elasticsearch. I gave them clever names. Logstash is your timber lorry, logging truck, if you will. Elasticsearch is the sawmill, and then Kibana at the end, wrapping it all together. How do you actually go look at that data? How do you visualize that data? How do you alert on that data? And that's Kibana. That's the front end tool set to be able to really take advantage of all the hard work that you've done to get those logs into your Elasticsearch environment. So I'll touch real quick on the architecture for remote endpoints. Because we're using Logstash, we can place Logstash in a DMZ node where your Windows 10, Windows 7, whatever the devices you have, they can still reach that DMZ Logstash node. And you can do this securely by using what's called mutual TLS authentication. So both sides have certain key pairs to be able to authenticate with each other to trust that type of connectivity and then send the logs. So the Windows devices, as long as they're connected to the internet, can send logs to that DMZ node. However, you don't want your internal nodes talking to the DMZ node. So what you can do is make sure that there's a firewall rule or something in between your internal Windows devices, so they can't get to that DMZ logstash node. So then you can already start to separate what's internal versus what's external. So anyways, so we have Windows devices. They're out on the coffee shop Wi-Fi. They're performing whatever activity they're doing, and they're sending logs to that DMZ node. Logstash takes those and then ships them over to Elastic and gets those ingested, and then we can look at those with Kibana. Any questions on the high-level view of what this remote architecture looks like?
Looks like you got a couple questions in chat there,
Sure.
Nick. So somebody asked, what's your mixed endpoint environment, Windows, OS X?
Great question. So 98, 95%. Well, I shouldn't say that. For our end users, it's like 95, 98% Windows. There's a handful of Macs sprinkled in there. For server infrastructure, it's going to be in that 90, 95% Windows, and you got those few Linux devices. But then when you look at all those other things, the appliances, the networking equipment, those types of things, those are going to be, who knows what Unix type system and those types of things. But for the most part, for the endpoint environment specifically, I would say most of this is Windows. And that's, like I said, that 9,000 numbers, what that is. You probably have that 30, 40 MacBooks out there that are a little outside the scope of this infrastructure. Hope that helps.
Perfect. And then I think you're going to get to this next question as you go in, but so as the alerts come in, is your team all looking at these, or is this something you guys outsource for investigations?
Awesome question. Yeah, I will get to that. Let's see. Well, I'll actually answer that now. So yeah, we handle all of the investigations ourselves. We don't outsource any of the telemetry that we gather, and everything, and I didn't mention this, everything we do is hosted on premise. We don't use Elastic in the cloud or anything like that. We do manage all of the infrastructure inside. So, and all of this is managed on a Windows infrastructure. We're not using Linux for all the Elastic nodes. We are using Windows because we are a Windows shop, so we can have our server admins support our Windows devices as we get those stood up and things. So, yeah, we have a dedicated team of 12 people, which is always growing as we see more areas to identify threats and work through these things. But yeah, so we've got a solid team that focuses on the alerts, and I will show what those some of those alerts a little bit later here. Great question.
Oh, that answered the next question, which is how big is your team? With the next one, how do you enroll the endpoints? Do you install the agents manually, or do you have an automated process with a lot of endpoints?
Awesome question. Awesome question. I'm so pumped for Fleet and what that capability is bringing. So we're always really paying close attention to that. We're not using that today. Something we're looking into. But for what we do, we actually have a tool set that deploys the software. And in a nutshell, it's PowerShell scripts. We have, because these are these devices that get stood up are stood up by a team inside of BIT. When they build those clones and those types of things, we've got the scripting to be able to say, hey, do you have WinLogBeat? Do you have Sysmon? No? Okay, well, I'm going to get those for you and download and make sure you get the latest versions. And then we have an ongoing cadence that it'll check once a day or at least, just check to see, okay, are you running the latest version of WinLogBeat? If not, then we'll go pull it down. That's where I think Fleet's going to be pretty huge, and that's what I'm excited for, what Elastic is bringing to the table with that. But today, yes, it's all PowerShell scripts that are kicked off in an automated fashion, but once the script has been designed, it's a matter of what devices do you want to push it to. Great question.
Perfect. And we'll take one more before you get to your next part.
Sure.
What is the size of your Elastic cluster to accomplish all this?
Yep. So I've really been focusing on the 9,000 endpoints. We've grown a lot since then. We've got a variety of other data in there, but we are running a 4-node cluster on premise. And just at a high level, if you want some of the actual specs on that, each Elasticsearch node is 40 gigabytes. So we're using half that for the heap. And then as far as storage goes, each of those servers has about 6 terabytes, if not more. We don't have it all full, of course. You might run into some issues with the amount of RAM storage ratio. I'll let the Elastic experts handle that part, but we do have an ample amount of storage available in event that we need to archive or do something with that data. So we are looking at in about a 30 to 45 day time frame. We're at about 9 billion events. And with that being said, some events we actually store forever, and some events we store for less than 24 hours. It depends on what the log source is. For example, inbound firewall denied traffic isn't very useful to us, but we need to have it for other purposes. So we only keep it around for 24 hours. And we use another functionality in Elastic to transform and aggregate that data. So we only keep the aggregation of the data, not the raw log. So there's things like that we're doing as well. But at a high level, we do use a four node cluster.
Perfect. And I guess we might as well answer this next one. What do we got to do to get you to open source that installation script?
That's a good question. And that's one thing that we've been trying to do the best that we can is provide some of these tools out there, because we're all fighting the same fight here, right? We're all trying to do the same thing. Why not get those tool sets out there? That's one thing. I don't have an ETA on that, but if I do, I'll definitely share it with the community, and Elastic maybe do a blog or something on it and get that posted out there. But definitely willing to share those things, as it's some of those things that everyone's doing. But with that being said, maybe Fleet will be here before we know it, and we might not have to. Maybe we'll do it that way, but who knows? We'll see.
Sure.
Great question. All right. I don't think I see any more in there. So good question. I like the interaction here. This is awesome. I appreciate it.
Yeah, keep them rolling in.
So with Logstash, and you can do this with Elastic ingest nodes as well. But speaking to Logstash, when that event from the coffee shop sends its Windows event logs to Logstash, you can use a mutate filter and add a tag and call it remote asset or wherever you want. So then I will show you here in a minute what you can do with that type of enrichment, because you want to know, okay, what's external and what's internal, because you might have a different set of risk to those assets. But what's awesome about Logstash is all the different mutate, also all the different enrichments you can do with it. This is one small example. But what we like to do is we like to enrich IP addresses with geo information to know maybe what country that source IP might be, or whatever it might be. So there's some cool stuff you can do with that. Here's a screenshot of a dashboard that with that specific tag, because I put that little tag in that mutate, if that's all you did, you can filter on that and you can see, I'm gonna use the laser pointer here. I just renamed the label external assets, but all I'm doing is saying tags is equal to remote asset. And I'm looking at a cadence of how often these machines are checking in and sending logs. So that's kind of cool. So right at a glance, I can see how many unique WinLogBeat agents are sending me logs over time. Easy to answer the question, especially, well, what's cool about this is this was implemented just a couple months before the pandemic hit. So it was actually perfect timing. So I was able to answer the question, how many machines do we have out there in the remote world that aren't on our network? I was able to go pull up this dashboard and I can show you this is what it's looking like. So that was pretty cool to be able to show that capability. I think we got somewhere up into 4,000 or 5,000. It was really cool to see that we had that functionality to be able to see what lurks out there. And just again, at a high level, sometimes you need to have those answers. Okay, what's our risk out there with all of our remote workforce? Then you can see how many logs you've got, and then break down by what type of event IDs are tripping, all that fun stuff that you can do with Kibana. I'll get rid of this laser pointer. All right. All right, now I'm going to get into a few SOC use cases. I've got 3 event IDs here. One that's built into Windows that I believe is just turned on by default. Someone can double check me on that. But with Windows Event failed logon, which is event ID 4625, that is in the security channel. 4625 is failed logon, and it gives you a lot of other detailed information on what that failed logon, about that failed logon. So that's one thing that, without a doubt, you want to bring that into your Elastic stack. The other two events are based on Sysmon. And like I said, Sysmon is a tool you can install and run. It runs as a driver. It records a lot of different things, similar to what an EDR solution will do. It'll grab registry entries. It'll get process creations, process exited, file deletions, and then there's a whole list of them. But at any rate, I'm going to focus on these two process creation events and DNS query and see what we can do with those. So we got a question here. Do you filter out noise from the ingested logs majorly on Sysmon? So great question. What we've done is, instead of filtering out noise from Sysmon, we kind of went the other way around, where we had a very focused team that would run Sysmon and put appropriate configurations in, see what the noise is, and then reevaluate and reapply a new config to the Sysmon so we don't log it. We don't have a Sysmon logging absolutely everything and then dropping what we don't want. Instead, we actually have it pretty focused. And where we started was the Swift on security. I think they had a repo out there that had like a template. Hey, you can use this for Sysmon. But then we moved to, I believe it was Olaf Hartong. He has a Sysmon config out there that maps to MITRE. So using those templates are a good starting spot. And what I would recommend, if you've never used Sysmon before, is get those templates, apply to one of your common devices, and see how noisy it is. Log those to a test environment and figure out, okay, these logs that are coming in, I can see where these are good and these ones not so good, and they're not going to be any value to me. So I don't even want to log that in the first place. And so that gets into a deeper discussion of, okay, am I going to go ahead and ignore every time that I see this in the tool set? An example of that would be, maybe you've got an endpoint security product, or maybe you have an inventory tool, or maybe you have something that is always noisy in your environment, doing something that, you know, if it were to be compromised, you probably have bigger problems, and that's not where you would detect it in Sysmon. So you're going to say, okay, I don't care about this specific process creating these events, so I'm going to exclude that from that config. So I would say we do that all up front in the Sysmon config, so we don't have to drop anything. Now, with that being said, there has been times where we've had to implement maybe some emergency drops of logs because maybe a specific device or a specific event that Sysmon was logging that was pushing a lot of events that we didn't want to see. So we drop the events, adjust the config, and then remove that dropped events filter and log stash, and then move on. Hopefully that answers your question there, Emmanuel. Good question. All right. So I'm going to talk on process creation events and DNS query events and what we can do with that. And I'm going to put a little plug in here for where I all started for me, probably 5 years ago, 6 years ago. I stumbled across malwarearchaeology.com cheat sheets, and they had a good list of, you know, these are the logs you should be looking at. That was an awesome reference. I believe Elastic's probably got some good ones out there too. I'm not sure, but I'm sure there's some really good cheat sheets out there to say, hey, look at these logs and see if you can get those into your environment. But very good resource, definitely recommend it. Even today, they still update this. All right. So I'm going to start with Sysmon and event ID 1, which is process create. So this is a nice quick win. And I have the KQL, which is the Grafana query language. That's what I use. Excuse me. And I'll get my laser pointer again here. Clicked links from Outlook. What's cool about this is we can identify when a link has been clicked from Outlook, because the way that the processes work, when you click on a link inside of the Outlook app, it actually has to spawn your browser and pass it the URL that it needs to open. And because of this, we can see when Outlook, a link gets clicked on and that browser is being spawned. So this is an example here. I got my host name and my username that initiated this event. And then I have the actual device operating system. This is all out of the box with WinLogBeat. You can enable host OS information so you know what the operating system is. So that might be helpful to you. And then this specific sysmon event is process create, and the process that was created was iexplore.exe. I don't show it in here in the field, but the parent process name was outlook.exe, and you can see it here in the filter. So all I care about is if the parent process is Outlook and the process arguments contain HTTP. And what you can see here is, okay, Outlook spun up iExplore or Internet Explorer, and you can see that here, and it passed it this URL. And you can see that I've got a good example on this machine where they clicked multiple links. And I did a demonstration where I actually used different browsers to show that it works with Internet Explorer, works with Microsoft Edge, and it works with Chrome. And what's even more amazing is that there's no network traffic here, so you can see HTTPS. You can get the full link, the exact thing that they clicked on, which might help you navigate back to the initial email that might have had the link inside of it. Because usually when you're working with HTTPS and you don't have like SSL inspection or something that's breaking out that full URL, you're only going to get a domain. So if all you had was elastic.co or slack.com, you don't have this full piece of information. It's going to be really hard to track maybe where that came from, if it was an email or if it was a specifically crafted URL that was a link to a file download that could be malicious. Well, you lose that information if you don't have the full URL. So click links from Outlook, I believe, is a big win, because then the next step is, okay, they clicked on the link, but did it pass the firewall successfully, or did the firewall knock it down because it's a malicious website or whatever that might be? So then you have to use the correlation factors from your IDS, your firewall, maybe your antivirus or EDR solution or something that's going to prevent that type of activity. So you can correlate that with something else. But again, the initial factor here, the initial finding is, okay, we know that somebody clicked on a link. Where do we need to go from there? So this gives you without a shadow of a doubt that activity had occurred. Any questions on that? Cool.
I don't see any questions, but I didn't know that, and it's awesome. So
yeah, and then the cool thing is that you get Sysmon, and Sysmon's free. You just drop it on there, and away you go. Like that's what's so cool about it. You don't have to pony up a bunch of money for a really fancy EDR solution to do that. You can just get that with the free tool. Moving along here, that same event ID, process create, we can do the same thing for attachments. So as you suspect, we'd have outlook.exe as the process parent name, and then let's look for doc, PPT, XLS, PDF. Throw in zip, throw in JS, throw in other extensions that you're interested about, and you can see not only is it just links we can find, but also documents that were opened up. So think of macro-enabled documents. Think of maybe malicious PDFs. There's all kinds of good opportunity there to look for it. Now, with that being said, you're going to see a lot of information that's like, well, they do this stuff all day long. What's the big deal? Well, the big deal is when you actually identify a specific system that might be compromised due to that, you can actually go back and look and see who else in the environment downloaded that same or clicked on that same link or clicked on that same attachment and opened it up. Again, you'll be able to correlate all of those things and have a much better picture and understand what actually happened. And here's the thing. If they're not on your network and they're not passing your firewall and all that fun stuff, you can't use that as a telemetry point anymore. So now you have to use these logs on the endpoint. So if someone's out, like I said, the use of the coffee shop example, you can tell when they click on the links outside your infrastructure. You don't know if that coffee shop's going to have a firewall to block that traffic. So you have to do some other investigation and know if that's good or bad. And then hopefully you have a tool to remotely manage or take care of that device. And if you can't, it might be the last thing you can do is call up that user and say, hey, notice you downloaded this malicious PDF that we are aware of, and I need you to shut your computer down right away, or whatever your process is to take care of that. So again, remember that remote remote access or that remote logging aspect, how important that can be. All right, Sysmon event ID 22. This is DNS request. So what's cool about this one is this is networking based by a process. So if a process makes a network connection or makes a DNS request, sorry, then you're going to get the DNS question name and then the status of that. So this is an example where I just made up a fake domain here. ElasticCon 2020 is here. I leveraged this during a presentation I did last year, obviously, but I use that as a domain to hit. And what I hit it with PowerShell, curl. I even tried to ping it, and with Chrome. So you can see the different processes that map to that specific question name. Because the biggest problem with just pure networking telemetry is that, yeah, you see that somebody tried to query that DNS name. Maybe you get that from the domain controller itself. But usually you're not going to have the information to know, okay, what process was it? You might have the device. Oh, great, I have this device. Now you got to take your shot at all the different processes that might have started that. If it was Chrome out the gate, it might not be that big of a deal. But if that was PowerShell doing that, now that's interesting. So because a Sysmon can gather that DNS activity based on process is a significant win, because it cuts down the analyst time trying to hunt down and figure out, okay, well, which process made that connectivity out to the internet. And so it's an example, and this is not a great one, but you can get the gist of it. If the DNS status was successful or whatever it might be, it'll list it here because Sysmon does record that type of activity. So again, very awesome use case. And there is another event ID that I didn't talk about here. It is event ID 3. It's the same. It's very similar, except for instead of DNS, it is network initiation. So if PowerShell made a connection to malware.com, it'll get the IP address and that type of information. So you can tell which process has made what network connections, which again is something that you can probably only get at the endpoint unless you have some type of firewall that can glean some of that from the endpoint itself. But again, just an awesome way to look at what processes are happening on the device to know, okay, is this malware or not malware? Obviously, there's more to it than that, but if you simplify it, those are the types of things you want to know the answers to right away. Is this Chrome making this activity, or is this some crazy weird binary or script that executed, tried to download maybe other malware or try to exfiltrate or whatever that might be? So again, just another example there. So this one is 4625, and this is the failed logon. What's cool about the failed logon, it gives you the status or the reason why it was failed. So if you were to ingest 4625, here's a sample of what you can see. We got the source IP address from which they're trying to log in from. That's significant, right? Like, why is this IP address trying to log in with administrator to this device? That makes no sense. Nobody should be logging into that. Or look at these users. That's strange. And they're all on the same device. So you're thinking, wow, multiple IP addresses, multiple usernames to the same device. And then we get the substatus of why it's failing. And in this example, it says this is just a misspelled or valid password. So that's a valid user account. Whereas down here, like these aren't even valid user accounts. So that's even more interesting is, okay, they're trying to log in with something that doesn't even exist. So this is a good example of some type of brute force login that has open reign or is open to the internet. As you can see, multiple users, multiple source IPs to a single host. And you can see the query I have up here. I want to look for everywhere that bad username or authentication information. So that's why this popped in here. And you can do these things as well, making sure you don't get the local stuff, right? Because sometimes there's some local authentication happens on a machine. So I just did some more cleanup to what I actually want to see. And this isn't based on the domain controller. This is based on the machine itself. You can get your domain controller authentication logs, and that's great too. But again, what about those devices that aren't on your domain? How are you going to gather when somebody's trying to log into your device? So, and then lastly down here, I could add this last bit in here, calling it saying and tags remote asset, and return just the devices that are remote that are trying to get authenticated into. So again, different aspects there. Good question, Kevin, on EQL. We haven't done much on the EQL, the event query language, yet, but these would be something that would be a great use case for. And I encourage everybody to look into the EQL and what they can do with exact examples like this. If you have so many successful or unsuccessful logins and then a successful one, that's interesting information. So EQL is a great addition, a great capability, but we haven't explored it to that detail yet. Good question. And then you want to visualize it. Here's a nice little threshold map. How many unique usernames. So you can see on the side here, unique count of usernames. If it ever breaches this, then there's something interesting going on. So you can see that this is about normal, because people are going to they're going to typo, right? They're going to put the wrong username in. So that is about a normal, but this is not normal, right? And this must have been when the machine was off, and this is back up again, right? So you can kind of see these things over time just based on a threshold. So there's threshold detection rules that you can build in Elastic to maybe help you with that as well. So between EQL and the different types of detection mechanisms, Kibana, there's a lot that you can do. All right, I'm going to try to round out this part here with some use cases between you leveraging the Elastic Stack and an open source tool called the Hive and also Cortex. They're both part of the same project, but I'll kind of show how can you integrate both of these. The Hive is an open source security incident response tool that allows you to document your investigations, record observables, those things that are interesting, and have playbooks or workflows on how you work through an investigation. Cortex allows you to enrich the current data. So for example, you get a IP address as an observable in the Hive. You want to get more information on that IP. You could query URL house or other types of sources. Say, what do you guys know about this IP address? Domains, file hashes. You can do those types of things with Cortex, and I'll show that here in a second. So inside of the Hive, we have built out a community Elasticsearch analyzer that is working on getting to be in the official repo, so that anybody can go get this analyzer. And actually today it's there. If you go to GitHub and Cortex, you can download this analyzer if you use the Hive today. But what it allows us to do is to run a query on something that's interesting in our environment. So in this example, I was wondering about this this elasticon2020ishere.com domain. So what this is showing here is this Elasticsearch analyzer that I ran this query inside of Elastic from the Hive, and it pulled those results into the Hive automatically. I didn't even have to go to Elastic. Once I was in the Hive and I had the information documented, this would return all the events in Elastic, and I have the index names over here. Then I have the source and destination IPs and ports that are relevant. But I just have some good examples of how you can integrate the Hive with the Elastic Stack. So doing all of that query and heavy lifting, so I don't have to go to Kibana and search for this information. I can do it natively inside of the Hive. And if you want more information on that, again, that's going to be under the on a GitHub repo for the Hive project under the Cortex analyzer. You should see the pull request, and I can get that specifically to anybody that is interested. So I've talked about a lot of the stack, and on the detection side, when it comes to the alerts, you can roll your own alerts, and based on specific information. Now, I know Elastic's been doing a lot of good work in this space with threat intelligence, and I encourage you to go look at their the threat intelligence module for FileBeat. But what we've been doing is when we know of something that's bad, whether it's IP or domain, we create we create a detection rule on that inside of Kibana, and we do that in a very automated fashion. And without getting too much into the weeds on that, what I want to show you here is that with detections inside of Kibana, again, you can specifically make those queries like source.ip is this, or source.domain, or destination.domain is this. I want to be able to get an alert on that and send that to my security incident response platform. So I want to get an alert and I want to send that to the Hive so an analyst can go look at that, because we know we've got a hit on something that's malicious. So here you can see an example of all of the detection alerts that we've created from the Hive, because we've integrated those two things. Every time we mark that as an IOC in the Hive, it creates a detection rule for us inside of Kibana. And then whenever it alerts, we can see what that looks like over time. So here's some samples of what those domains and IPs are and when they had occurred. So it's really nice that in Kibana, you can look at your detections as they fire over time. And then for us, we actually have a tag on, okay, give me all the stuff that we've actually vetted out ourselves. So then we can narrow in on how we've been doing this with security operations. So to tie all that together, this is what a sample architecture would look like to be able to not only bring the events in, but also integrating into the Hive to be able to do more of that incident response. Now, this doesn't have to be the Hive, right? Plug in whatever maybe SOAR tool that you might have. But because the information's in Elastic, we leverage webhooks from the Hive and we leverage webhooks from Kibana so they can talk to each other. So when something happens in the Hive, I want an action to occur. I want to have to push something to Kibana, and maybe the other way around. I want Kibana to push something to the Hive. It's a two-way street. Now, using webhooks in Kibana, though, last I checked, and Elastic folks on the call can correct me if I'm wrong, but the webhook does require a gold license to do that. Is that still correct? Does anyone on the call know here if it still requires a gold license for using webhook actions in Kibana?
You're not supposed to be testing my knowledge here, Nick. That's a good question. I'll have to find out. I think it does, but
okay,
I'm not 100% sure.
Otherwise, I've seen people do something similar to sending alerts to the Hive from their Elastic instance using Elastalert. I'm not sure how well that tool set is supported or how well it works. We've never used it, but you could also use a PowerShell script. I know for a while today we still leverage some PowerShell scripts to read in an email inbox and look at those emails and ingest those into Elastic and send an alert to the Hive. So pick your tool that you want to send into the Hive as the alert, but the main thing is getting from Elastic into the Hive is your key. However you do that, whatever tool you use is up to you. But bridging that gap can be very significant to help bolster the analyst's capabilities to effectively identify if it's an IOC in Elastic. How can they quickly search for that and maybe not have to pivot back and forth between Kibana and the Hive? So what I'm showing here is you can do all of that fun infrastructure where you tie it all together. But on the Cortex side, again, that's where our response and our analyzers come into play. So let's say we get a specific file hash, or maybe we have a file specifically. We can send it off to Cuckoo for analysis. We can check virus total, check FortiGuard Labs. I know they have a threat intel feed and a bunch of other ones. But I also have Cortex is the main engine to query Elastic and get the results back into the Hive. So that Cortex analyzer I spoke of earlier, what we do is we use Cortex, we use that analyzer to query Elastic, get the details we want, feed it back into the Hive, and it's all documented there. I don't have to copy and paste from Kibana. I don't have to do any of that. It's automatically documented in the Hive with the Cortex analyzer to search Elastic for us. And then lastly, responders. This is fun where maybe you need to respond via an email, that type of thing. That's where they come into play. Not really much of a use case for responders for Kibana at this point, but yeah. So that's another high level view of what Cortex can do in combination with the Hive. So with that, I covered quite a bit of content. And that's all I really had. Is there any questions, comments, anything you want to dive deeper into?
Feel free to come off mute and ask any questions you guys want, or just post them in chat.
Working on it. Working on some machine learning. Stephen asked the question, do you do anything with the machine learning? We do have a license to leverage the machine learning. We've actually rebuilt our Elastic infrastructure to accommodate another node that can be specifically for machine learning. And we've had some, our biggest experiences, we had one job with machine learning that would detect anomalous login activity based on country, and it actually worked pretty well. We saw it work in an instance where using Azure logs, the sign-in activity logs, that is able to tell across all the users which ones were anomalous and then report and give us alerts saying, hey, this user, this is very anomalous and it has a scoring rating on it and enough to go make you look, and you go check it out, and then you can say, yeah, this actually is a compromised user that we need to deal with. So that's been the tip of the iceberg, but where we want to really expand it is using all of those built-in machine learning jobs that Elastic has put all that good hard work and effort into building out, and take advantage of those and have a dedicated node for that, because it will take some resources to kind of crank through and crunch those logs to spit out the information that we seek. But great question. Let's see, you got a question. Any comments on how this works versus XDR solutions? So I don't have much experience with XDR solutions, but I have a feeling that it's a similar concept. I don't know how these would integrate, if it would be XDR would be a replacement of some of these components or in addition to, but I don't have enough exposure to that term of extended detection response, I believe is what that stands for, and how that all comes together. So for us, we are working on whatever we can do to make the analysts' lives more efficient and effective when they perform the day-to-day analysts. We don't want to get burned out on repetitive tasks. We want to clean those things up. So the process comes first. We spend 85% on the process, and then once we have it down and we know something's repeatable, that's where we can start working with the automation. But maybe with the XDR stuff, maybe a lot of stuff comes out of the box. I don't know. So there is some work that we probably do more than maybe what an XDR solution could do out of the box. But without going further into understanding what some of those solutions are, I couldn't give you a more definitive answer than that. Good question. Any other questions?
I got one for you if no one else will chime in here. So as people are getting started with Elastic, Nick, how did you, I guess, get traction internally in your organization as bringing in something open source to a foundational organization like you have there?
So for us, I would say demonstrating the value of what we had. When I could show them, hey, I can tell you what specific process made that network connection and show it visually, show how this can benefit, then that was, I think, what really took hold and what kind of impressed the upper levels of, okay, this makes sense. Let's go after this. Because when you show them the price tag, oh yeah, you can go get this other solution, do this for you, but it's going to cost X amount of dollars. Like, that's not going to work. Well, okay, this is what I can do. This is what, and this is how I'm going to do it. And that seems to satisfy that answer. The open source wasn't as much of an issue because of the company that's behind it, right? This isn't like a two-person shop that's got this tool out there that's open source, right? Elastic is a very large, successful organization that's behind it. So I think they get a lot more traction when you actually have a company behind something that's open source, not just, again, the few people, like 3 or 4 people out there trying to keep a project alive. And the support factor, being able to have support available and acquiring a license that allows you to call and ask Elastic help, or ask for help when things are severely broken or whatever I might have done to break the infrastructure. So I think that peace of mind, having a company that has willing to support the product.
Fantastic. You got one more in here in chat. How are you handling all the ECS changes with your custom log sources?
Oh, great question,
Sounds fun
Kevin.
already.
So that's a good one. I would say that our custom log sources, we really try to push and use as much of the Elastic out of the box stuff that we can. The ones that we can't, I will say they don't get opted as frequently as they need to be, but we haven't seen any issues with, for example, running ECS version 1.5 when I think 1.9 or even newer than that's probably already out. We don't see any issues there yet, but I can definitely see where it would be good to maybe be focused on that a little bit closer, because I know at the time when we're building these things out, not all the ECS fields existed. And that was kind of like, it was great to have ECS, but we're at a point where, I'd love to map all these things out, but there's no fields for them yet. And that's where I kind of want to lead to this point before I get pulled away. I would like to mention working with the Elastic community is huge for all of this, because some people might have already done that work for you. Like, oh yeah, I've already done all the ECS for, this specific data set, and you can maybe collaborate on that, but also use the GitHub repos and all that fun stuff to ensure that, hey, what is the latest and greatest for the ECS and what's coming down the pipeline. So, I mean, there's a lot of benefit of the community and posting issues like that. Hey, I'm trying to map all of these things. I need some assistance. Definitely use your community members, and I'm also in that Slack quite a bit as well. So you might see me kind of asking questions and stuff, and it's always a great tool. But the ECS is always on the back of my mind. It makes sense to update where necessary, but I wouldn't say we go log source to log source like, oh, new version ECS, let's go update, because most of the time we get the core stuff that we need, that we work with on a daily basis.
Assuming you have a bunch of logs and an index which you are visualizing in the Kibana after creating an index pattern, do you provide an ability to extract a certain part of a big log description and leverage that information to visualize in dashboards? For instance, can I extract file number 00321? This is a sample log with file 00321 and some other information.
You can do it, but there's a bunch of different ways you can extract specific text out of there, but yeah, it's possible.
They hopped off.
Grok expressions, yeah,
they hopped off. I'll email them if I got the email. I'll see if I can touch base with them and answer that.
Yeah, I think that's definitely definitely doable with Grok, right? Just Grok expressions, if it's consistent. I mean, that should be pretty doable. I think you might be able to documentation for that. So
that, or you could probably write out some type of query or something like that too.
Yeah.
You can use.
I'll see if they got there.
I think you use the exclude clause too in the Grok pattern. It's a bunch of things you can do there.
Mm-hmm.